Okay, let's just do some random log questions. Okay. This one is log base 3, log base 3. Okay, so we're fine with that. So we can use the rule. We have log A of something minus log A of something else. It's going to be log A of that thing over log A of that thing. Okay, so is it going to work? Yeah, that's going to work. We can keep that x squared there. All right, so log 3 27x over 3x squared. So that's obviously, we can simplify that a bit more. So we can say that that's log 3 of 9 over x. So that x is going to cancel with that x, and the 27 divided by 3 is 9. So that's 9 over x. And I guess we could actually rewrite that, because then we would get wouldn't we? And we know that log 3 of 9 is 2, because obviously 3 squared is 9, minus log 3 of x, whatever x is. And we know that x must be greater than 0, because otherwise that would be a negative number. And that's about it, really. Yeah, that will do for now. All right, next one. Let's have a look. All right. So for this one here, I think we can do it two ways. 3. So 27 is going to be 3 to the power of 3 squared is 9, 3, isn't it? So we could do it one of two ways. We could say that 3, the 2x minus 1 equals 3 to the power of 3. And remember our rule, when am equals an, then m must equal n. So therefore 2x minus 1 equals 3. So 2x equals 4. X must be equal to 2. That's one way we have of doing it. The other way we would have of doing it is to take the log of both sides. So 2x minus 1 log 3 equals log of 27. Doesn't matter what the base is. So 2x minus 1 equals log of 27 over log of 3. And remember, that does not equal log of 27 over 3. Okay, it doesn't equal that. And I think that's going to give us a number. So if we just put log 27 over log 3, log 27 divided by log of 3, I think we're going to get a whole number, aren't we? 3, yes. So 2x minus 1 equals 3. So add 1 to both sides, so 2x equals 4, and it follows that x equals 2. Are there any limits on that? No, because when we take the log, yep, there's only one answer. So there we go. X equals 2 is our solution. Okay. Looking at this one. Okay, I can see two ways of doing this one as well. let's split it in half. So we could bring this log over to this side. So we would have log base 5 2x minus 1 minus log base 5 of x minus 3 equals 1. And that would be log base 5 of 2x minus 1 over x minus 3 equals 1. And we raise both to the power of 5. So 2x minus 1 over x minus 3 equals, is that going to work? So 5 to the power of 1 is 5. I think that's going to work, yes. So bring this, multiply both sides by x minus 3. So 2x minus 1 equals 5x minus 3. Let's just come up here a bit. So 2x minus 1 equals 5x minus 15. And let's bring this negative 1 over and the 5x over. So negative 3x equals negative 14. So x is going to be equal to 14 over 3. And I guess we can say that x doesn't equal 3, so we're fine there. X doesn't equal 2x minus 1. Yep, we're fine there. And x doesn't equal positive 3, so we're fine there. So there's our answer there. The other way we would have of doing it is to convert the 1 to log base 5. And our 1 is going to be equal to log base 5 of 5. And then we would have log base 5 2x minus 1 is going to be equal to log 5 of 5 plus log base 5 of x minus 3. I'm just being careful I don't go off the page. And then we were going to have log base 5 2x minus 1 is going to be equal to log base 5. These two multiplied by each other, 5x minus 15. And then we raise both to the power of 5. So 2x minus 1 equals 5x minus 15. Bring them both over. So negative 3x equals negative 14. This is exactly what we had before. So x is going to be equal to 14 over 3. Again, same answer. Cool. All right, same questions. Okay, so this is sort of crying out, but they have the same base, so it's sort of crying out to be multiplied together. So log 2 x minus 2 is going to be equal to log base 2 of x squared minus 2x. So log base 2 of x squared minus 2x must be equal to 3. So let's raise both to the power of 2. So 2 to the power of that equals 2 to the power of that, and they disappear. So x squared minus 2x equals 3. 2 to the power of 3 is 8. So, and let's bring this 8 across. So x squared minus 2x minus 8 equals 0. And now we just have a quadratic. So let's factorize it by solving it. I think that's probably work. 2 that multiply to give us negative 2. So it's going to be minus 4 and x plus 2. So x is going to be equal to either 4 or minus 2. But we know from this one here, x cannot equal negative 2, because then we would take the log of a negative number, and we can do that. It's going to be, I think, it would be what, 2 I minus, I think it's I minus pi over log 2, I think. It would be an imaginary number. It would have I in it, so it cannot be that. So x equals 4 is our only legitimate answer. Right, excuse the little pause there. I had to get a pit stop. So this one here, how are we going to go about doing this one? Let's bring this 2 over, so that we have log base 10 of x squared, I think, minus log base 10 of x minus 1. And I want to get rid of this one. That's log base 10 of 10. Okay. And that means that we're going to have x squared over x minus 1 equals log 10 of 10, and it sounds like my sister is here. So then if we raise both sides to power of 10, I don't know if you could hear the dog, if you can hear my dog going nuts. Let's move that down a bit. So we get x squared over x minus 1 equals 10. And if we bring the denominator over, multiply it, so we're going to get x squared equals 10x minus 10. Bring this back over, minus 10x minus 10 equals 0, and that's not going to factorize. No, there's no two numbers that multiply to give us negative 10 and add to give us negative 10. So we're going to need to use the quadratic equation. So I'm just going to move this question down a bit. So now our A is 1, our B is negative 10, and C is negative 10. We could just use the calculator, I guess. And let's do the b squared minus 4ac bit first. So negative 10 squared is 100 minus 4 times 1 times negative 10. Okay, so that's going to become a positive. So 100 plus 40 is going to be our determinant. So it's going to be minus b, so it's going to be 10 plus n minus the square root of 140 over 2 times 1, which is 2. It's going to give us our answers. Let's do it on the calculator. So let's do it on equation solver for polynomial. It's degree 2, and it is this one here. So 1 x squared minus 10 minus 10. Yep, it's going to give us those two answers. All right, so are both of those answers legitimate? Well, we have, if that's a negative number, so this one here is not going to be a legitimate answer. That's going to give us a negative number for when we take the log. So our only legitimate answer is going to be that one there, isn't it? Okay. All right, this one. So let's, two ways we have of solving this one just by looking at it. Either we can do it by indices and not even use logs. So we know that 9 is 3 squared, and we know that 27 is 3 cubed. So 9 to the power of x is going to be equal to 3 to the power of 3x, 2x, and 27x minus 1 is going to be equal to 3 to the power of 3x minus 3, and now they both have the same base. Remember, a to the power of m equals a to the power of n, then m must equal n. So 3 to the power of 2x equals 3 to the power of 3x minus 3. That means that 2x must equal 3x minus 3. So minus x equals minus 3. So x must equal 3 there. And then if we take the logs of, do it by logs, so x log of 9 equals x minus 1 log of 27. Is that going to help us? It's going to make life actually a little bit more complicated, isn't it? But it's going to be x over x minus 1 is going to be equal to log of 27 over log of 9, and that's going to be a whole number. It's going to be 3, isn't it? Is it? So log of 27 divided by log of 9, 1.5. So x over x minus 1 equals 1.5. So x is going to be equal to 1.5x minus 1.5. So negative 0.5x equals negative 1.5. X is going to be equal to negative 1.5 over negative 0.5, and it's going to be equal to 3, which is the same answer that we got before. Are there any things there that it cannot be equal to? Well, x can't be equal to 1, and that doesn't meet that criteria. So, okay, we're fine with that. Okay, evaluate log base 3 of 20. So, two ways we could do it. We could just shove it in the calculator. We could go to setup, and we're going to go to math, and then we're going to go to math, log base 3 of 20, 2.7268, and 1 is to 3 significant figures, so 2.7 3. 2.73. Or we could use the change of base. So natural log of 20 over natural log of 3. And it's going to give us the same answer. .72, same numbers. Okay. For this one, let's separate these out. So it's going to be natural log of 2. I'm going to use natural logs. And this one, natural log of 2 plus natural log of 5x. Sorry, x 5 to the power of x. And that's going to be equal to natural log of 2 plus x natural log of 5. Okay. And if we take the natural log of the other side, equals x plus 1 natural log of 3. Is that going to help us? I think if we expand out this bracket, we get x natural log of 3 plus natural log of 3. Is that going to work? Yes, it's going to work. So we have natural log of 2 plus x natural log of 5. It's going to be equal to x natural log of 3 plus the natural log of 3. And let's bring all the terms with x over to one side and all the terms without x over to one side. So it's going to be x natural log of 5 minus x natural log of 3 is going to be equal to natural log of 3 minus natural log of 2. So x is natural log of 5 minus natural log of 3. It's going to equal that. We come up here, x is going to be equal to natural log of 3 minus natural log of 2 all over natural log of 5 minus natural log of 3. Whoa, okay. Let's see if our calculator can solve this straight away. I'll be interested to see. Let's see if it can do it. So 2 times 5 to the power of x equals 3 to the power of x plus 1. Can it do it? Can do it. Oh, look at that. There we go. There's our answer. But it's also going to be that as well. Or is it? Now, this is definitely not equal to 48. Natural log of 3 minus the natural log of 2, remember the base doesn't matter, divided by natural log of 5 minus natural log of 3 is going to be nowhere near 48. It's going to be that, isn't it? How did it get 48? It's very, very strange. That is really, really strange. Let's see what it gives us next time. So I cleared everything off. So 2 times 5 to the power of x equals 3 to the power x plus 1, and you have to put those brackets in for these Casio calculators, minus 48. Well, that can't be right. And then it's just getting more and more ridiculous. Okay, so we proved that the calculator cannot actually find it, but it can very confidently proclaim an answer that's obviously wrong. Okay, but that's not the answer. The answer is, in fact, natural log of 3 minus the natural log of 2 divided by the natural log of 5 minus the natural log of 3, and it's going to be that number there. All right, so sorry about that, but we've got new neighbors moving in next door, and the dog goes nuts from time to time. So we've got solve log base half. Okay, base half. And we've got an inequality and a negative number. So those are our complicating factors. But I don't think it's going to complicate things too much. So let's just exponentiate everything. Half to the power of x minus 1. So greater than half to the power of negative 2, negative 1 over 2. So that's going to be x minus 1. That and that are going to cancel. Must be greater than, so half to the power of negative, it was negative 2. To the power of negative 2. I think it's going to be 4, isn't it? So 0.5 to the power of negative 2 is going to be 4, yes. So x minus 1 must be greater than 4. Therefore, x must be greater than 5. And I think x cannot be equal to 1. But I mean, that doesn't really matter anyway. All right, hydrogen ion is 3.2 times 10 to the power of negative 5 moles per litre. Find the pH, where pH is the negative log 10 of the concentration of hydrogen ions. Well, we want the pH is therefore going to be equal to negative log 10 of 3.2 times 10 to the negative 5, because it's already in moles per litres, and they already give us the concentration. Okay, by the way, in chemistry the square brackets means concentration, so it's the amount per mole per litre, number of moles per litre. Be careful when you do chemistry with your brackets. The different brackets mean different things. So this is going to be just a matter of putting it in our calculator now, I guess. Let's clear that. So negative log, and it's already base 10, 3.2 to the power of negative 5, 4.49. 4.49, and you really want it at 3 significant figures, so we'll keep it like that. I think that's it. I think that's all my examples that I found. Yes. All right, we're done. Hooray.